We're a veteran run podcast just hanging out, swapping stories, and tossing around wild ideas. Having a good laugh along the way. Pull up a chair, grab a drink, and join us as we talk about whatever comes to mind and have a blast doing it. And don't forget to look into the description, and we have a 10% code for W. Whether you need to be hydrated or given a boost of energy, W has the answer. Tonight, we have returning guests, Disease, Gamer, Inventor, along with Dave, Machinist, for different contractors to include Blue Origin and SpaceX. Welcome back, guys.
Hello, hello.
Thanks for having me.
So, tonight, Disease wants to talk about a theory he's had.
I've had it for a while.
Some of you may find it entertaining or interesting. I haven't had the full gist of it yet, but we're about to get it.
I'm ready for it. As a scientist myself, ancient astronaut theorist.
Ah, ancient Chinese secret, eh?
I gotta put my hair gel in real quick.
I want to preface this that I'm not a scientist. I just, kind of, this is how I see things and how they, I see them working. Um, and you might have to like forget everything you know about, the old trope, forget everything you know about how things work. Um, the the initial thing is it's hard to start like where should I start because I have to go between the atomic all the way to the planetary scale and back and forth at points. So in order to understand it, first I'd have to tell you how the fields work, right? In my theory, there's only basically three fields. There's not the weak and strong nuclear. There is electromagnetic. We know that one exists. And then gravitation. In mine, gravitation is just more attraction, right? So I'll say the attractive force instead of like gravitation because if you say gravitation, then you think about, what has already been pretty much established or what they think is established. So, uh, sorry, I forgot to look up something. Um, a very smart man once said, if you can't explain something simply enough, then you just don't understand it well enough. Um, so, hopefully, this is simple enough for me to understand because I'll be the one explaining it. So, it's going to be hard to do. Um, so, first of all, the attractive force is uh, what I'll explain first. The main difference in my theory and the theories that are out there is the shape of the fields. So I'm going to show you a picture of what I think the field looks like for the attractive or the gravitational once it reaches that size. Whoops, I hit the wrong one. All right, so this is very simple drawing. Obviously, I drew it in paint, so it's very simple. So the red is just your atom, basically. It can be your planet as well, and the field is either oval or it doesn't have to be oval. It could actually be just a kind of like a cone, you know, emitting from the whatever's causing this force or emanating, you know, this force. So this field is not just stationary; it also rotates around, and that. Here, I'll show you another picture of it. So that causes the field to be stronger in when it's closer to the object or to the atom, and weaker when it's farther away. And because the field is rotating, the frequency of the field will tell you how strong it is, how far out you are. And I was showing you the other picture earlier about the gravitational wave. And this is the reason gravity looks like a wave, because if you take a field and you rotate it like that, it's going to appear like a wave, right?
Yeah.
So that's why they think gravity is a wave, but it's not. It's actually just the rotation of the field, because the field's not a perfect circle. And that's how I believe that the attractive force works. And if you notice, I kind of covered the backside of the atom or the planet with the field as well, and that's because at some point that field is going to be there at all times. So when you get close enough, it's going to be there at all times. So that would be your strong force, and then whoops, I gotta stop fat finger and stuff. And the outer part would be your weaker, like nuclear type of forces, where they pull from further away, but they're not quite as strong, right? Any questions so far?
That's basically like the idea that like satellites get sucked into our gravitational field, and the closer they get, the more powerful that attraction into our atmosphere becomes.
Yes, yeah. And the sun is the same way.
Yeah.
Every astral body does too. But this also occurs on the atomic level, right? So I'm going to show you another picture in a second. But the second force is obviously electromagnetic, right? And electromagnetic can be polarity based, right? So you can have an electron who is positively charged or negatively charged, and it may be pushed away or pulled in depending on that charge. But the third force that I'm going to talk about is something you don't really hear about. Nobody talks about it because they don't know about it. It's the repulsive force. So the reason I believe there's a repulsive force is because the quarks themselves, the elementary particles that the atoms are made of, they don't fall into each other. They're repulsed by something, right? Even the electron is repulsed by something because it doesn't fall into the atom. It stays in outer bands. So I'm going to show you a picture of what I drew. This is just a basic atom. But hopefully the picture will kind of explain the forces that I'm talking about. So the blue is the attractive, like we talked about already. See the oval shape. And like I said, it could be oval or it could be a cone that just gets weaker as it goes further out or away from the emanating point. The red is the repulsive. And I believe it's kind of a degrading, circular field, but I think it's kind of off to one side. It kind of wobbles. And then the electromagnetic would be your purple. Now this is not to scale, obviously. This is just an example of what I see it being like. So the repulsive is probably going to be far smaller or weaker in a way, but it's the balance between these forces that will tell you where the electron is going to sit. So in this one, the electron will probably sit in this spot right here, and as all the fields are going to rotate somewhat. They're going to move. So as they move, it will stay in that little channel where the strongest attraction is at, and the repulsive will also kind of keep it in balance as well, but it will stay where that's the strongest. And as you stack atoms more and more, so this would be like a simple hydrogen atom, right? So you would have one electron and then your proton, neutron, or just your proton. Where when it gets more complex, when fusion happens, and those atoms have to be, they have more electrons because they have more protons. So this field will stack, and you'll have like one here and one here and one here, and the electrons will attract to it, and then you'll get like this, like I showed you, like that. So as you have more protons, those fields they're not going to be in line with each other. They'll basically, the electrons will follow, whichever one is most attracted to, or the one it was already attracted to. Any questions again so far?
Nope, I think I get it.
Okay. I'm going to turn the page and see what I have written. my writing is very horrible. I thought a 3-year-old wrote this at first,
So-
but I realized it's myself.
As you're talking about unified field theory,
Mm-hmm.
what can you explain to the viewers what unified means in like
Well-
I don't know,
Okay.
like a fifth
it's
grade?
it's pretty simple. The theories that are out there about the universe, how gravity works, how the atoms work, they're not unified because they break down at the atomic level, or they'll break down at the um, astronomical level, because they're trying to quantify it numerically, right? And in order to quantify something numerically, you pretty much have to have every variable understood. Not every single one, but almost every variable understood. So it's very hard to quantify gravitation and rotation and all these things, and they've been trying to do so with what they currently have, the model they currently have. And that's on the atomic scale as well as the, like I said, the astronomical scale. It's hard to explain that without getting too technical with it, but that's the gist of it. Does that sound about right, Dave?
Yeah.
All right. Sorry, I'm looking through my notes to make sure I've explained it. Okay. So now that I've explained the fields, I wanted to kind of go over a larger scale. Okay. Now, when you have an object that can support its own weight, right? It's not compressed. In hydraulics, you're told that liquids cannot be compressed, right? Well, under normal circumstances, a human can't compress a liquid. However, a planet can. The pressure is so intense, it can actually compress a liquid. The reason I say that is because if something can support its own weight, these fields, like this, will, let's see if I don't remember which one. See if I find the picture. Oh, okay. It's very crude, but so imagine the green line is the object, right? And that is the atoms there, obviously, are the atoms on the outer edges of it. So they're all lined up on the outer edge. They're all producing their fields, right? So this object, if it can support its own weight, it doesn't produce what we would consider gravity. It has an attraction, but it's very short range because of the outer layer of atoms, right? Does that make sense?
Yeah.
Okay. As you compress something, right? So like this, imagine if this was water or steel or iron, and you compressed it down, if you could, into something that's a lot smaller, right? Like a quarter the size, right? Well, where do these fields go? Right?
I would assume
you
they
would
get
think-
closer to one another.
They will stack, yes. But where do you think they want to remain?
In their original position.
Exactly. So while they will compress somewhat and the fields will kind of follow suit, they will start to extend beyond the bounds of this object more and more, the more compression occurs. So if you scale this up, let's say you have a planet the size of Earth, right? And it's made of nothing but water or hydrogen. It doesn't really matter, just something that's pretty simple. Let's just say it's water. Let's even go smaller than that. Let's say you're in outer space and you can breathe for some reason, and you have a ball of water that's like 40 foot in diameter. And if you get in that water, are you going to feel some pressure from the water?
I would assume some. I mean, it still has
A little bit.
Still has
you would
mass,
feel a little
right?
bit. And it's still going to be attracted to itself. So you're going to feel something, a little bit. It won't be much. Now, if you dive deeper in that water, you're going to feel more pressure?
No, I would assume not. Not in space.
Why not?
I would assume because the idea of zero gravity. I don't know. I don't know.
Well,
I'm about as ignorant as they come with this stuff.
water automatically forms a ball, right, in outer space.
Yes.
Okay. So that means that attraction is pulling it into that shape. And that attraction will eventually create pressure on the atoms lower than it because they're all pulling in to each other, right? And as that ball gets bigger and bigger, it'll eventually create so much pressure that it will compress the water itself. So when you scale that ball up to a planetary size, right?
The core is going to
And
be heavy, I guess you could say.
hold on, you're going too far, sir. Back up. Offensive line, 5 yards back. Okay, yes, it will be. But I say that because if you had a planet that is just solid water, right? Let's say solid water. Only a few miles below the surface, it becomes what's called ice 7. And I'll explain what ice 7 is. Normal ice is created due to temperature, right? Below 32 degrees or 0 degrees for you UK people. It turns into a crystalline structure. Ice 7 is the pressure from the liquid above is so great it causes the atoms to push together into a crystalline structure. So it's creating basically diamond hard substance using ice, right? And there's even layers further than that. There's even ice 13, which they created in the lab. And years ago I said that this would happen, and I was laughed at by a few people. But I also said there's stuff that's even denser than ice 7. Ice 13, there's probably ice 24, there's probably, as you go deeper and deeper, it's going to create structures that are stronger and can support the layers above without collapsing into a singularity or fusion.
Ryan said same field but smaller.
Same. Huh? What field?
Whenever you're talking about the circular field there.
The picture I got up now? I'm not sure what he means.
No, I'm not sure.
I'll have to. Ryan, if you have any questions, you have my number.
Or you can ask specifically what question.
Oh, I guess he
Same.
means the same field on the planetary scale as the atomic. Yes, but it's a bit different, and I'm going to get more into that as I get more into the planetary side and how that works in that respect. I'll wait for Dave to finish until we continue.
All right, making noise.
Oh, that's all right. I just didn't know if you could hear. So if you scale this ball up even larger, right? Let's say it's not. I don't want to use something more complex than hydrogen, because hydrogen's mostly what stars are going to be made of, especially early universe, right? So if you have a ball of hydrogen in outer space the size of a star, a few miles down, what do you think you're going to find?
I mean, all the different ice levels, depending on how far.
Yeah, you're going to find like a hydrogen 7, an ice 7 variant, like something. So eventually the atoms will be compressed to the point they turn into a solid too, no matter what it's made of. Doesn't matter if it's oxygen, doesn't matter. It will be forced into a crystalline structure by the weight above it. And that's only a few miles deep, like 10, 15 miles. It depends on what the atoms are, because obviously, oxygen is going to be heavier than hydrogen, so it's going to probably happen sooner, with oxygen or anything down the periodic table. But as it compresses more and more, those fields, I guess I can stop sharing this, but I was gonna, I've shown all this stuff. So they know about neutron material, right? Neutron material is hyper compressed matter, 10,000 times compression. And most likely that's still from one of the outer layers of a star. The inner layers, we really don't know how far matter can be compressed. So if you can imagine, you know, a, a, a ball of, a star, uncompressed, totally uncompressed, right? If the sun was totally uncompressed, its outer diameter would be larger than our solar system, far larger, because it is probably compressed hundreds of thousands of times. We don't know. But it's this compression that allows these fields to extend beyond the borders of its, of itself. And that's where we get gravity from. That's when it starts to attract everything and not just the close things or the things it is normally attracted to, right? So like hydrogen is normally attracted to oxygen and other things. But when that compression gets that far and those fields expand, it starts attracting everything. It starts pulling in everything. And also, if the compression is large enough, then even the fields themselves, the fields of the the fields between the quarks, even those can go beyond the borders of the object. And then you're talking about fundamental forces that are even stronger, that we don't really even understand yet, but that's how far that compression goes. Any questions so far?
Yeah, I got one. So, alright, who was the first person to think about the unified field theory?
The first person?
Yeah. Wouldn't that have been Einstein?
Well, he's the first one to try and create a unified field theory. Not sure if he's the first one to actually try to make one or come up with the idea. I'm not sure. It would have to be after knowing that they're there, because Newton, he knew about gravity just because of the effects of it, but he didn't know exactly what it was. I don't know, I'd have to look that up.
It says, I'm looking something kind of up here. The term was coined by Einstein. So I think, yeah, it was like people kind of knew it existed, but he's the one that came up with the term. He's the most prominently associated with the concept.
Yeah.
So I wonder why he couldn't finish the theory. Because it was never complete.
No, Einstein was a mathematician, and he was very good at math, like Hawking, but better. And like I said, with math, you have to pretty much know all the variables. Einstein was figuring out the variables as he went along, but he didn't understand things the way we do now. Like if he had the instruments and every technology we have now, I think he probably would.
Yeah, he was extremely limited by our technology back then.
Yeah. But I'm referring to things in my theory. I like to make associations based on what we currently know as much as I can. So when I say the field is like oval or well, you can see the effects of that because our solar system is pretty much flat. So like all the planets are pretty much in line. They're not completely, dead in line, but for the most part they are. Now,
That and along with gravity keeping us on the Earth.
yeah. And so that's why I said the field goes kind of around the object like a cone or an oval. Otherwise, you'd be thrown off on one side and attracted to the other. Another thing is the field's rotation. I would guess, this is my guess, that the Earth's field rotates at the frequency of the Earth, which is I think like 16.9 hertz or something, gigahertz or something. I forget exactly what it is, but that's what I would assume the rotational speed is of the field. But if I am correct, and we could link the field size Yeah, he didn't have an iPad, that's for sure. If we could link the field size to compression, we would know exactly how, you know, much matter is there. So currently we don't. They keep saying that there's dark matter or dark energy. But if we can compress matter hundreds of thousands of times or 100,000 times, then that's where all the matter is gone. It's there, it's just hyper compressed.
Yeah.
Um,
It says here Earth frequency is approximately 7.83 hertz.
7 point. Okay. All right. Any other questions so far?
Not at the moment.
Does it make sense so far?
Uh, the majority of it, I'm no scientist, but I understand the fields, and there's different fields along with gravitational force, stuff like that. Um,
Is there
slightly.
is there
Go
anything
ahead.
that can't be compressed?
No, not to my knowledge. Well, not that I would think, because matter really can't be created or destroyed. It can only be changed, right? So you reach a certain point of compression where, uh, usually, let's say with the star that is a ball of hydrogen, right? Before it becomes a star, it it it, it still has gravity. It's still going to pull things in because of its size and the compression. But once fusion starts, and fusion starts at the core or near the core, because of the pressure, because it's forcing the atoms together at extreme pressures and basically forcing fusion to occur uh, that way instead of, like a burning or a temperature reason. Um, I also wanted to say too that, you know, well, Rob, you might know this too. You know the purpose of the radiator cap on your car, right?
I know it maintains a certain amount of pressure,
Yep.
um, so that it flows correctly throughout the system.
It's that, and so it won't boil out. For every pound of pressure you put on water, it raises the boiling point 3 degrees. So most of your radiator caps are like 13 pounds or 14 pounds, somewhere in there. Now, why does that occur? Right? Why does pressure cause temperature to change? But it doesn't really cause temperature to change. That's kind of a misnomer. But why does it cause excitement, the
I don't
excitement
know.
level, to
I
increase?
would I would say the closer you get to a vacuum, the easier it would be to boil, wouldn't it?
Yep. You can actually boil water at room temperature. If you go, it depends on the room temperature, but I think it's, if you do 28 inches of vacuum, water will boil even at like 30 some degrees.
Man, you trying to make me show my little smarts here.
I mean, someone
So
has to. It's not me.
I told you this was going to be in depth. I'm trying to make it where everyone can understand it. Uh, the so pressure is important, um, to kind of keep the excitement level down, right? So the more pressure you put on atoms, it takes more temperature for them to become excited to the same degree. So if you tried to boil water at 1,000 feet below sea level, it's going to take like 225, 235 degrees before it's going to boil. Um, so when you are taking atoms and you're compressing them, they're also heating up, but that pressure is also keeping their excitement levels lower. So it kind of stacks. That excitement level is pushing against the pressure, but the pressure is causing, it's really hard to think about in that way. Um, but I just thought it was neat because as you go successive levels down in something that large, you have to think about the pressure versus the excitement level of the atoms. So how I would think it would work is you're going to go through a layer that is solid, then a layer that's liquid, then a layer that's solid, then a layer that's liquid again. And it's hard to imagine that because you would think it would all have to be solid. But, density will tell you where they're going to sit at in that level. And so the hyper compressed things are going to be, or the more pressure, the more compressed they are, the deeper they're going to go. And as you add fusion into that, that will tell you where it's going to go, because it's going to go even deeper because now it's even heavier. But an interesting thing happens in fusion. So when you fuse two atoms, another side note too, the first fusion that happens is actually hydrogen to hydrogen, right? It's like hydrogen 1 to hydrogen 2, because hydrogen has two different states, or two different atoms. One is a proton and an electron, and the other is a proton, a neutron, and an electron. So the first fusion that happens is between hydrogen and deuterium. Deuterium is like hydrogen 2. And then once that occurs, once you get to that point, then you can fuse to helium and the successive elements. Now there's probably a in-between phase there too, elements that we don't even know about, but they only occur in extreme states of pressure under that fusion. But as those things occur, tell me what happens when you take an atom here and an atom here and you fuse it together, right? Like that. Ha! So, you know what? This is a good example. So when these two fuse together, tell me what happened. Did they take up more space or less?
Less.
Exactly.
I would say less because you're compressing, right? You're combining into one.
So what happens when you take up less space in a hyper-compressed zone? You relieve some of the pressure.
Yes.
Does that make sense now?
Yeah.
As you relieve the pressure. Okay, let me do it a different way. You people out there who are doing your own distillery, right? You're making your own moonshine, right? And as you take the alcohol.
What do you mean, you people?
You people, you know who you are. The ones I love who give me free alcohol. So as you distill something, as you distill alcohol, the alcohol will reach a certain temperature and then it'll plateau, right? And that'll tell you what alcohol is being burned off because of the plateau phase. That is because the pressure is equalizing, right? Those alcohol molecules at that temperature are expanding. Is it shrinking? No, they're expanding, so it makes the temperature stay at one point, right? Something similar happens with fusion, but it's kind of the opposite, I would think. I don't know, I could be wrong about that part. But I believe that the pressure actually drops because they say when you fuse deuterium into helium, you actually lower, the temperature actually lowers in the sun. And they can tell that through, I guess, spectrometers and stuff. And the only reason I could figure that it lowers is because you're actually getting more space in there. Because as things are fusing, you're taking up less space. And it's also why stars tend to shrink as they age. They can expand, but they tend to shrink. But they get far, far, far denser. And as the density increases, those fields extend further and further beyond the bounds of the star. So the smaller star will probably maintain the same gravitational field as a larger star. To some degree. I mean, as you produce photons, that is actually some mass. It's not a lot of mass, but it's some mass. And over billions of years, losing photons, you're going to lose some mass. So you're going to lose a little bit of those fields. Size. But. Anything else? Any other questions?
Can we see any of these invisible fields?
No, they're invisible. But you can see the actions of
Trick question though. Had to try.
I too have lost mass over the years.
I
That's not
seem to
true.
keep getting it. I don't know what's going on.
It's trading
That
off.
reminds,
I,
that
I'm
reminds-
taking I'm taking all your protons. Thank you.
Give me all your protons. That reminds me of Peter Griffin when he's like throwing stuff around him. He's like, "What the heck is that?" That's gravity, Peter. Because he gotten so big, he's like had his own gravity. So basically, I'm gonna try and sum it up. So when an object can support its own weight, it doesn't produce gravity as such, as we know it. It does produce an attractive force, obviously, because all the atoms do, but it's only going to be a little ways around the object itself. As pressure is increased and that atomic structure is condensed further and further and further and further, those fields still want to stay where they were, so they will kind of, in a way, expand, right? And I'll explain how they can do that and how they can expand. Not really expand. I should just say want to remain where they were and kind of reach those areas. So my idea of what is at the core of Earth is a bit different than most modern scientists. What I think is at the center of Earth is, or the center of the star, or Jupiter, or Uranus even, is basically a gigantic atom, right? It's not an atom as the way we think of an atom, but the matter has been compressed to the point where the electrons can't move, and so what they do is they try and migrate to regions that have less pressure for them, because electrons like to move; they don't like to sit still. So what happens to me is that you'll have this huge mass of protons and neutrons, and then at the top and the bottom you'll have your upper and your lower electrons, or your positive or your negative or whatever charges will be there, because there's like a 0, there's a 1, a 2, a -1, -2 electron. Anyway, it's kind of getting in the weeds with that, but so I think it's kind of the electrons go to the top and bottom, right? Because you have that rotational field, right? The pull, and so that's where most of your pressure is going to be located, because it's going to be pulling at the center. You're still going to be pulling top and bottom, but there's a tiny bit different, right? The top and bottom are going to be a tiny bit less, and the electrons will want to migrate to where that's less. Now we're talking about extreme pressures. Like, I'm not talking about it happens just easily. No. Extreme pressures. And this is what will give you your poles too. That's why Earth has a north and south pole as well, because of the positive and negative electrons, stacking on the pole, on the ends of the super atom, I guess it was. But I say that, and I know a lot of people say, no, there's no way that happens. But I also have to explain black holes. So do you want me to explain black holes now? Or you want to save that for another time?
Is this scientific black holes, or?
No. This is fringe disease theory black holes.
All right.
I knew you were going to say that, Reggie.
We all saw that coming. I saw the fingers typing.
So
I
just
knew
so
it was
y'all
coming.
know, Reggie, my producer, it uses my name as well. So
Yeah, they don't let
just
the
so we
producer
make it
change
clear,
their name.
Reggie has seen a few black holes.
He's seen some shiz. All right, so you want to get into black holes? Not you, Reggie. I'm talking about the people here.
Yeah, let's get into some black holes.
All right. So, first off, black holes aren't holes. All right? That's a misnomer. And I'll explain that. So, if you have what we've already established, a hypercompressed core of a sun, right? And you blow away the layers of it, right? Now, I don't know how many layers you'll have to, explode away from it. I don't know how big the core is going to be when this occurs, but you have this ball that is now far smaller, that is hyper compressed, and its gravitational force, right, is not being pressed in on by the surrounding layers, right? It's not being affected by the surrounding layers. So that field, that's when the expansion happens, right? That's when It's kind of like when you have a magnet and you put iron around it. The field kind of extends, but it's not as strong. But if you take those iron pieces away and you just have that neodymium magnet, it's insanely strong, right?
Yeah.
That is what happens when a star explodes. The outer layers come off, and that inner core is left. So the gravitation just from that inner core is so intense that light gets bent around it. That's why you can't see it. The light will bend around it. During this time, what a black hole does, it does the opposite of a star. A star takes the first few elements, creates all the others, right, through fusion. A black hole takes all the heavy elements and destroys them back into the base elements through insane gravity. So as it's pulling everything back in, that stuff is crashing together. And if you think about it, right, it can pull in light, a near massless particle, right? It can pull it in. What do you think it's doing to the heavier stuff?
Yeah.
It's
Like
ripping it apart.
exponentially faster.
Yes, it is pulling it in at near light speed because light can't escape it. So what do you think that's going to do? It's going to rip everything back to the base elements, right? And stuff's going to crash into each other, and it's going to cause it to break apart as well. This doesn't mean nothing survives it. It just that's its purpose. The star is a cathode, and the black hole is an anode. It's just a part of the solar life of the universe.
So basically,
I
all
don't
that's
believe-
left would be like the base elements.
Yes, it could even break everything back down into quark level stuff. We don't know. But as it continues its journey, it will eventually, if it gets enough energy and gets enough mass, atoms and everything, it will eventually slow down. It'll stop, doing what it's doing, and it will reform into a star. But some pieces will be left behind. Some pieces of that hyperdense matter that exploded from near the core. What will happen with those is, when that star explodes, usually it's spinning, right? So when it explodes, you'll have to go out in every direction. But the stuff that's parallel with it, some of that will be recaptured because the field itself is larger there and stronger there. So you'll have some pieces recaptured. What those pieces do is they will start absorbing or pulling in the close matter that they can, and those form your planets. Those hyperdense pieces of star form the planets because they'll capture the other pieces. And as it finishes its journey, whatever it winds up being, it may have one planet, it may have 2 planets, it may have 9 planets, or 8 planets and a protoplanet.
So me being a complete idiot when it comes to this, are you saying that a star explodes, creates a black hole, then those pieces, they go out into wherever, and they start gathering up on themselves, creating the planets? Does that mean that the star that exploded is also restarting its process and basically beginning anew?
Yep. Breaks
So
everything back down,
you
pulls it
think-
back in, but I'm sorry, go ahead.
So the star's not going to have the same amount of energy as before it exploded, correct? So
No, it won't.
It wouldn't be a star anymore, right?
Well, that's why I said it would have to absorb enough energy or mass, and then it could. But that's why, some of them will. Some of them will absorb a whole nother star or planet system or whatever, and they'll get enough mass, and they will become a star again.
Basically restart its engine?
Yeah.
Well,
It just
Now-
depends. I mean, you need fuel for the fire.
Right.
That's what happens.
just
And it
to be-
also emits stuff. Oh, go ahead.
I'm gonna get off topic just for a second. Reggie, I took care of the scammer on Twitch. You might have seen that message come through.
Another one?
Yeah, I got rid of that.
Do you want more viewers? Pay me.
Just buy viewers. They're so easy to buy.
If you ain't chatbotting, are you even trying?
All right. Any questions about that?
Nope, I think I understand that. Like I said, it's you have to destroy something to create it. Is what I'm getting in the long run of it.
Yeah.
And it won't be as strong or as powerful.
Well, it can be. It depends
It
on how
can be,
much it
yes.
absorbs. Yeah. Because you do have supermassive black holes. Now, those are hard for me to even understand in my theory, but I'll tell you what I think they are. I think supermassive black holes are basically quark level black holes. They started as quarks during the early universe, right? So they are hyper compressed quark matter. They're not like our normal black holes that we would think about that is like a star that is exploded. These are proto. They've been here since the beginning of the universe. And what they do is they are the regenerators. So if you have a solar system like ours, right, and the sun burns out, loses its energy, becomes a dud, right? Eventually, it'll work its way to the center of the galaxy, and it will be absorbed by the black hole at the center. Doesn't mean it's going to stay in the center. It may be ripped apart by the black hole at the center, and then it may eject some of it. Depends.
Would you say an asteroid would be part of a star that may have exploded, just being sent across the universe?
I doubt it because the star would be hyper compressed. So most likely an asteroid is just maybe some leftover material that wasn't fully absorbed, or
Close
it could
planet.
be part of a planet. Yeah, a planet that got ripped apart during it or during the explosion or whatever.
So if these asteroids and meteors, they, like in our solar system, they travel by us and they start heading towards the sun because the pull. Is that almost like it refueling itself? Like, is it gaining? It's gaining mass if it hits the sun.
Yeah, it can. Any mass is going to help out when it comes to that, whether it's a star or a black
And
hole.
obviously, yeah, like on that scale, it's going to take a lot. Like it's
Yeah.
it's
Yeah.
almost unnoticeable probably when something happens unless it's huge. I mean,
Well, most stars only have like one or two planets, right? So whenever a asteroid or anything gets pulled in, the star usually has a far more effect on it than in our solar system, because we have the four gas giants at the end, right? So those four gas giants have a gigantic field themselves, and it's like a shield for the Earth. So if it weren't for the four gas giants, we'd be getting hit all the time.
intelligent design.
Exactly.
It's the only thing that makes
That-
sense.
Mm-hmm.
I mean, it is pretty scary to think about how much like the asteroid belt and stuff, like how we're always like cruising through it, and nothing ever really hits us.
Yep.
That's a crazy thought to just like, yeah, we're kind of just pretty vulnerable.
Well, if it weren't for the four gas giants, we would be hit a lot more. A lot more. They pull stuff in themselves, and then what they don't pull in, if it gets close enough to us, usually the sun will pull it in the rest of the way, or it'll kind of deflect it. So we're very fortunate to have those four.
What are the four? We got what? Jupiter, Saturn, Neptune.
Yep, and Uranus, or Uranus, if you don't want to be
I like Uranus.
nasty about
It's
it.
much cooler.
So, do you remember what I was talking about, the moon being a superconductor?
Yes.
Okay. Well, hypermatter, or hypercondensed matter, when it reaches a certain point, and it depends on what it is made of, when it reaches a certain point, pretty much all matter will become a superconductor, because the atoms will be forced together so closely that electrons can flow freely across them. But if you think about something like hydrogen, right? It's very simple, so it has to be very compressed for that to occur. But if you take something like silver, then silver, you probably wouldn't have to compress it much for it to become a superconductor, because silver has 3 valence electrons that it basically can give up freely. So if you hypercompress silver, it would be I would call it a hyperconductor, or even a mega ultra mighty morphing Power Ranger conductor. You know what I mean? I'm making fun of it, but you see what I'm saying, right? So the moon, what I believe happened with the moon is, the moon was a chunk of that hypercompressed matter from, either early universe, or when our sun went supernova, black hole, and is now regenerated. It was a chunk of that hypercompressed matter, but it was by the Earth, which was a larger chunk. So they were never like one, but they were close enough. But as the moon during the early phases, it kind of cooled off after the explosion or what happened. As it cooled off, some of that, some of what it was made of was probably a liquid, and that liquid, now that it wasn't under the compression of the sun, it expanded and became a ball around a core. So that's why it's like hollow. And so either the core is still a superconductor or that ball could still be a superconductor. It just depends on how compressed it still is. And the reason I say it's a superconductor is because it's tidally locked to Earth. It's, we only see one side of it.
Right.
So that kind of stands to reason, because when you see a superconductor and they create these imperfections in it and they put it on a magnet, it goes dunk, and it stays in that position. And then they throw it around a rail and it stays in that position just like the moon does. So that's why I think it is. Also, I think that the magnetism from the Earth is actually manipulated by the moon, and that's what causes our tides or helps to, increase them. And
What do you think about? What do you think about that theory about the moon's hollow?
I just explained it.
No, but what I mean is, you see, if you look through a telescope, there's so many, like, impact. Wouldn't you think this thing would at some point crack and fracture off, or you think it's thick enough to withstand all the impacts from space? I mean, some of those craters are massive.
Oh yeah. Two things. I don't think it's completely hollow. What I think it is it's like a basketball, but it's got a core underneath it. So when something impacts it, it's either filled with some kind of really heavy gas. Because, okay, I also think there's hypercompressed gas, right? There's gas that is very, very heavy, heavier than most metals, but it's still in gaseous form. So when the moon expanded, the way I said, and created that layer, some of the under layers could have expanded back into a gaseous form. And so it basically created this
a void,
air bladder.
Yeah.
Huh?
Like a void.
Yeah. It's like an air bladder, but it's able to absorb impact. It could even be a material that is like oobleck, where the harder you hit it, the more it pushes back and absorbs the impact. There's so many things that could be created under that much pressure. We have no idea. No idea. There's certain, to put it this way, atoms are so amazing because certain molecules cannot be created unless they're under pressure. And once they're taken out of that pressure, it's called an isotope. They will eventually decay and they'll separate. And that's just the pressure we can put stuff under. So you can't imagine the stuff that's like further down below the mantle of Earth or in the sun itself. There's some crazy stuff in there. We have no idea what matter can actually do at that not only temperature, which is, like I said, excitement level, but pressure. And then depending on the layer and the excitement level and the pressure and the layer and the excitement. And then as you go deeper as well, each layer above it is putting more and more pressure on the layer below it's not an additive fashion, it's a multiplicative fashion, because each layer is progressively heavier. So it's even more compacted than most people realize.
I mean, I think it's kind of similar to like in the scuba diving world, right? It's only water, right? It's salt water wherever you're at. But there's a multiplier, and you have to do your like timetables, and it's like, well, if you're diving at 30 feet, you got this much time with the tank, and it's like, oh, well, now you're at 60 feet. Well, now you have to like do this math equation to figure out like the air is going to be compressed in your tank. You're going to use it more. It's like the crazy level multiplier the deeper you go.
And you have to have certain gases in the tank for different depths sometimes.
Yep. I'm nitrox certified, and that's like the better gas to have in a deeper, which I forgot what nitrox specifically, obviously, is like nitrogen and enhanced oxygen.
Yeah.
And it's like if you're going on a deeper dive, you want nitrox.
Yeah. Nitrogen won't compress back into a liquid unless it's above 600 psi and 88 degrees Fahrenheit, something like that. So it'll stay in gaseous form under a lot of pressure, so long as the temperature doesn't drop below 88 degrees. It's I looked into it because I was looking into nitrogen. No, I'm sorry, I was wrong. I was thinking of CO2. Nitrogen's even worse. Nitrogen takes even more pressure. I mean, not more pressure, less pressure, but more temperature. I think it's I don't know. Some of that stuff gets mixed up in my head, but yeah. So if let's say, for instance, right, if something was, if there was a void in Earth and Earth was hollow, right, and you go down miles and miles down, and it's normal air, right? What do you think happens to that air when it gets more and more pressure on it?
I don't want to say it would get thicker, but it kind of would, right? Like,
Yeah. Eventually, probably, what I would assume is that eventually some of the components of the air would become liquid.
right, you'd turn into like a liquid oxygen.
Yeah. Or liquid nitrogen, or or not nitrogen because that's probably hard to do, but oxygen and carbon dioxide. Because if you go to the, I think it's the North and the South Pole, during a certain period of time, when the temperature drops to 110 degrees negative, it will actually snow dry ice. The CO2 or carbon dioxide in the air will actually freeze and come out of the air. And pressure can kind of do the same depending on the temperature, of course. So a hollow Earth might work somewhat. It would just depend on how deep, because eventually you would get deep enough where the pressure would probably be too much, for one, and things would start to, do that. Liquefy out of there. Which is weird to think about.
Yeah. What is the deepest we've dug? I think it was Russia, or was it China? Someone did like a drill hole. They tried to go super deep.
Yeah, supposedly Russia dug one 6 miles, I think 6 or 7.
Didn't they say something about they found something and closed it off?
Kola super deep
Supposedly.
borehole at a depth of 7.6 miles.
There's only so deep you can drill because the matter becomes so compressed that like even diamond bits will break. See, what I think not country
The obstacle that stopped it was high temperatures. They reached 180 degrees Celsius and they had to abandon it.
yeah.
Hey,
At that
Which,
point,
that's Celsius, so that's pretty warm.
yeah, your drill bits are going to lose temper and all that at that rate. So they couldn't go any deeper. But what I think the tectonic plates are floating on is like a layer of diamond. And as they move, that layer will kind of get trapped and brought up with like the volcanoes and stuff. And that's why you'll have like diamond mines and stuff are usually by volcanic activity.
Yeah.
Because the tectonic plates are actually floating on a layer of liquid diamond.
God, only if we could dig there.
That supposedly, now this is not part of my theory, this is a conspiracy theory. There was an expedition someone did a long time ago. I heard about it. I don't remember who it was that did it or any of that, but supposedly they found a cave that went really deep, and they found just gigantic crystals and like
Journey to the center of the earth.
diamonds and stuff. No, this was a long time ago. I mean, they could have taken it from that, but it was some conspiracy that they found something like that. Like, that'd be cool. Yeah.
Ryan said nothing WD-40 won't fix. That was for the drill.
Our drill's not working, sir. Have you tried WD-40? Just pour it in. It looks like I'm kind of looking at a little diagram of the hole. It started going straight, then it started getting real crooked. And it's probably because they were hitting all that material and their drill was just not
They had to
like
go
deflecting.
around stuff. Yeah, they had to go
Yeah, so
around
they,
stuff.
They started drilling it in 1970 and continued till 1992. So it took a
Wow.
minute.
That is a long time to drill a hole.
Somebody was trying to find hell.
So they would have if they hit that magma layer. I'm sure it'd come flying out.
And create their own volcano.
I think I pretty much explained everything. Any questions?
So you're saying there's not an alien base in the moon, though?
No.
There
Not
may
that I know
be human bases soon. if not already.
We'll see.
Yeah. They said that a long time ago. They had the helium-3 they wanted to mine from the moon or something because it was a good source of energy. But the moon is so dusty, and the dust is like very, very bad. Like it just wears away everything. It's like working in the sand all the time. Make a moon. It would be nice to make one, but
So, what would you imagine the tiniest thing in the universe being besides an atom?
well, as far as
Think
our
there's something
understanding
smaller?
now, well, yeah, there's quarks. I was talking about them earlier.
That's like the
particles
smallest thing that we know about, right?
that we know about. Yes, so it could even go smaller than quarks. We don't know. And the thing is, I don't think with our current level we could even measure anything smaller than a quark. We can barely measure a quark because the way they measure it is using magnetism. Well, magnetism has a rate. It has a frequency. So if something is smaller than a quark, and the quark is barely picked up, if something's smaller than a quark, it's very likely it would, go through that field no problem, and you'd never see it. So our instruments aren't sensitive enough to sense anything smaller than a quark, if there is anything.
So Ryan's still on the moon, I think. He said some people say it's cold at the center and not hot on Earth. And then materials hit possibly nanite. Nanonite?
Nan-
He just typed in nanonite.
You mean nano level material? Meaning that it's really compressed, and that's basically what all the nano stuff is. They just align it better, and so the atoms are closer together. So when you hear that, like, what is the term now? I don't forgot the term.
Well, while you're thinking of that, what gets me every time about theories is how does a scientist test the ideas of, when they can't see anything? Like, if they can't see it, how do they know? How do they test theories when you can't see what you're trying to test?
Well, they have come up with some ways, like they did with the hadron collider. Am I saying that right?
Yeah.
The
The
super
crazy
collider.
loop. Yeah.
Yeah, that's what they built it for, was to test certain things like that. And then they also have this one that's dug deep underground, and it's like a pool of, I don't remember if it's water or some kind of super cool liquid, that they are testing for neutrinos to see if they can sense neutrino activity, because they're not sure if neutrinos exist. So there are scientists and people out there who are testing these things. It's just you learn a little bit, but then the problem with learning a little bit about the universe is a lot of times it kicks you in the nuts and you get kicked back like 5 steps, and you're like, what the heck? And you don't know what you're looking at. What I find annoying though is some of these wild theories, like dark matter and dark energy. Now I was very adamant that dark energy didn't exist, but now that I've kind of changed my stance on that. I actually believe that the black holes, these dark stars, I think they actually do produce a type of energy that we can't see, that may be going faster than light speed, something like neutrinos, and that's kind of the cathode to the sun's anode. The photon and the neutrino, they're kind of the opposites of each other, but they interact with each other, and they function in a way that we are not sure, but I'm pretty sure they just feed each other, like the one feeds the other in some type of way. There's always a reason for something like that, But to test it, like, let's say with my theory, could I test any of this? Not really, but do I have some proofs of it? Well, yes. I use reasoning and the way things work. I mean, obviously, you've been listening to me for almost, over an hour now. And I haven't even gotten, like, real deep in the weeds, like, that with ICE-13 that they created in a lab and what it could do. ICE-13 is actually a superconductor. I didn't say that, but it is. And I theorized that years ago, 20 years ago. I said that, and I was laughed at by people who were, not scientists, but even science. Well, no, it wasn't a few of them. It was on a science website. Anyway, a lot of problems with science and scientists today is they think they know everything when they know a tiny, tiny fraction of it, right? They take a tiny fraction, they run with it, and then, instead of just taking what we know and working with what we know, right? And that's why you get all these wild things like dark matter, dark energy, and that kind of stuff. Not saying that dark energy doesn't. I don't think dark matter exists. I really don't believe in dark matter. Dark energy, possibly because of, like I said, black holes. But the reason they think there's dark matter is because there's fields that there's interactions they see that they can't explain. But if you, follow my theory actually kind of explains this. A standard source for what information?
About this theory.
My theory? Or just theories in general? Well, quite frankly, there is no source for, like, legit information on those things. Now, because most of this is theoretical, right? String theory, all these other theories is theoretical. There's no proof of them. They get proved as time moves on, right? Like my theory. I believe my theory has been proved with things like pulsars, right? If you look up what a pulsar is, it's a star that's kind of gone supernova but didn't turn to a black hole. And out the poles of it, it shoots radiation. And if my theory is correct, this radiation is heavy electron radiation. Because remember what I said, the electrons migrate to the poles of the core of the star or the planet. It becomes this big atom. And if I'm right, this star out the poles would be your electrons. But I mean, it's not like it's not worth reading about those things. It's just like when you watch Discovery, right? And they tell you, oh, this creature evolved from this creature. You have to take that with a grain of salt because they don't know. They weren't there. They didn't see it.
Right.
And the wild leaps in logic that they use have been proved false many times. I mean, I remember when I was a kid, they were saying the coelacanth was the fish that walked on land and became everything else. And then they find it's still alive.
Yeah.
And then they said it was 90 million years old. And then next thing you know, it's 160 million years old. And the last I heard, I think it's 400 million years old. So you see what I'm saying? The facts always change. And
If I'm not mistaken, when you speak about that kind of time frame, there was a recent correction in, dating certain artifacts. There was what did I say? So, say, for example, I was reading an article and they said that this artifact was like, say, 90 million years old, right?
Yeah.
Well, then they were basing it off of something
carbon-14.
that wasn't correct. And when
Yeah.
somebody had proven that it was way off, and from 90,000 or 90 million years, it ended up being like thousands of years old, not 90 million.
Yeah.
So, there's always mistakes in scientific findings. As technology increases and gets better, we are able to, better, identify and, date these things.
Yeah,
So maybe.
Go ahead. I'm sorry.
So maybe we can find a way to use the unified field theory, to maybe possibly travel in space faster without, taking a toll on the human body.
Yeah, my thoughts on like faster than light travel is a little different because I don't see light as the end all be all that a lot of people do. I don't think that it takes billions of joules of energy to do this, and it's like, well, I don't know. We don't know because we can't get that far right now. I do believe that there are things that move faster than light. I actually think the quarks move faster than light. the pieces that the atoms are made of, I think they move faster than light, and that's why light is reflected off of them. If they didn't move faster than light, light would go right through them, right? You wouldn't have light bouncing off of them. And I mean, of course you do have some light absorption. That's why, this shirt is black, or the thing, is purple behind me, because it's reflecting all the other light but that one, right? So it does absorb some, but why would it reflect light when light's a massless particle in the first place, or near massless? To me, it would have to be moving insanely fast to be able to reflect it. Whereas most scientists would say that's impossible, they can't move faster than light. But I'm like, well, what if atoms are blips, right? You're seeing a blip of something. So what I imagine atoms are, they're moving faster than light. And when we are trying to measure them or quantify them, what we're doing is we're looking at a car tire on the road. We're looking at somebody's rim as they're going down the road, and we're seeing that rim go forward, and then we're seeing it spin backward, because of that frequency. It spins backward. And then all of a sudden it spins back forward again. And then it'll spin backward depending on how fast you're going. You know what I'm talking about?
Yeah.
How the rim looks like it's going forward, and then it'll look like it's going backward.
Mm-hmm.
Well, if that atom is moving at multiples of the speed of light or something like that, we're probably seeing that frequency at that certain point, where it's going backwards when it's actually going forward at massive amounts of speed. And another reason I think they're moving faster than light is because the light particle itself comes from them. When they fuse, the light particle is given off. If they didn't move faster than light, if they didn't move faster than light, then how could light be trapped inside them and be given off during fusion, right? Make sense?
Yeah, I think that we limit ourselves with the idea, like you were saying, like, we know everything. Maybe. Probably not, though.
No.
Light is the fastest. How can you definitively say that?
Yeah, we can't fathom anything faster, because we see, by using light. So if we can't see it, it don't exist.
That's it, unless they have spinners.
Yeah.
They're going to make a comeback?
They never left. They're always in style.
In some areas. Yeah. See what
But
with this theory, do you believe in aliens?
Not really. I think.
Oh, go ahead. As vast as the universe is, could there possibly be another Earth? In another galaxy? I mean, think about it. Why design this massive galaxy and only have one planet with just a bunch of dumb humans? Yeah, I mean, not to say we're all dumb, but, we're definitely in a decline when it comes to, being sharp, so to speak. I mean, watch the news. You see it.
Yeah.
Yeah, but that's not our fault. That's not our fault. That's the fault of the people who are in power. That's the fault of the people who don't teach kids the way they should. That's the fault of the people who want for themselves instead of sharing with everyone. You see, if people would share information instead of hoarding it, then we could advance. But we can't advance because people are too tied up on the monetary side of the physical side of it, like what's in it for me type of thing, right? And so you can't advance that way. You can't share ideas that way if you hoard it to yourself because you're worried about money and, funding and all that stuff. And another thing, a lot of the science now we're going to have to redo because it was for many years funding over facts. So whoever was funding you, right, you wanted to make sure that your scientific study worked out in their favor, right?
Yeah.
So there's so many studies.
Publish.
Yeah. There's so many studies that are just complete bunk. And it's all because the funding came from a certain source. It's like that should never be the case.
Yeah.
Can you imagine the amount of information that got destroyed when Hitler ordered, the books to be burned out of the library?
Yeah.
I mean, every time they've done that, basically, Carthage, any of the book brands,
Pompeii.
there's stuff we find in our libraries. They're not even that old. That almost worked.
That area 51, yeah. Um, I I don't know that that because the government scientists they're pretty good. Like they're very secretive. There's always been these theories about aliens, and they found aliens, and they're reverse engineering stuff from aliens and all this. But the universe is so vast that I think if there were life on another planet, it would be billions of years before we'd ever even find out about it, unless we, not I wouldn't say billion, but until we develop interstellar travel, if we ever do. I think a lot of civilizations would probably destroy themselves before they ever got to that point, because
We're
unfortunately,
well on our way. We're
Yeah.
pretty good at that.
Yep.
because
History
selfishness
repeats
reigns.
itself.
When you teach a society to be selfish, to be all about me, it's only a matter of time before that society falls. Because nothing can stand by itself, right? You can't build a house with one support. You have to have multiple. And society is the same way. You have to have good people, and you have to have people there willing to support each other. And all that's pretty much gone now.
I would say you're not going to find that anymore.
No. That's why Einstein was probably the last Einstein, right? Because you don't have that kind of society anymore that props up people who are smart, people who are, he was a patent lawyer, right? And he come up with theories, and they didn't just shoot him down. I'm sure they did a little bit, but when they saw how genius he was, he,
I think he was autistic, wasn't he? A slight autism.
I don't know if he was. I'm sure he may have been on the spectrum somewhere, but I do know he was very good with numbers, and some of the times autism can be that way, but I don't know. Yeah,
I'm trying to think what is like the savant. He might have been like a little bit of that
Savant,
kind of little smart.
maybe that's what. But he did more of the number side things. That's why all his his equations and everything, and he wanted to quantify everything with equations. But like I said before, you have to know the variables.
Yeah.
And without knowing the variables, he came up with some amazing things. Still, it boggles my mind how he discovered those things. But even E equals mc squared will break down in certain points. That's why it wasn't the unified field theory. That's why he kept going further. He even had a theory about repulsive forces, but he couldn't quantify it. He didn't have a way to see how they worked and interacted. And while I believe there is a repulsive force, I think the repulsive force is also what keeps the moon away from Earth and keeps the Earth away from the sun. I don't believe you can have 4 attractive forces and those forces not pull something in all the way. You have to have something pushing back against, otherwise it's gonna pull it in.
Yeah.
If I tie a rope to you and I pull you once, I'm gonna pull you in. If I pull you 4 times, you're probably gonna hit me. So there has to be some type of thing to push away, and that's why I kind of came up with this theory, is that the balance between the repulsive, the attractive, and the electromagnetic, depending on which one of those is being repulsed or attracted, or maybe 2 are repulsed and 1's attracted, you'll sit further out, or maybe 1's being repulsed and 2 are attracted, you'll be further in, right? And that it's not just the thing pulling you, you're producing that field too. I mean, not you, but I'm talking about the other, like the moon is producing a repulsive and an attractive force too. So you have to combine that in, and that will tell you whether it's going to be closer or further away. So just, it made more sense to me. Like I said, I'm not a scientist. I just kind of reason these things out by what I've seen, seen in the universe, and how every time we look out, we see a star, and it's got like a planet, and they're almost always in line. I don't know if we've ever found one where they weren't in line with the with the spin of the sun. There's got to be a reason for that, right?
Right. Yeah, everything's like a dinner plate. It's not. They're not all over the place.
Even our Milky Way galaxy is, right? So that would lead credence to my theory being correct as far as the field itself, as far as the attractive field. Now, you could debate the uh, repulsive, or we already know about the electromagnetic. But as far as the attractive, I think I'm pretty solid on that.
We will see in our lifetime, probably. We just gotta get Elon to Mars. That's what we gotta do.
Well, maybe my theory will help him. You just gotta tell him that.
I don't know, man. I mean, as long as him and Trump can make up or something, because what Trump threatening to deport him? Like,
Well,
come on, man. You're like two brothers trying to fight.
The problem is he wants those EV subsidies. That's the whole reason he's fighting Trump. And I understand it, but I also understand the other side where it's kind of not fair to the others either. It's
Yeah,
not fair
yeah.
for me to give EV subsidies to you, but the gas engine companies don't get any. It's basically, telling them, oh, you might as well just shut down. So I can understand that. And I can also understand Elon's point too, because, he doesn't want to lose those subsidies because he's going to lose a lot of money. He's going to, his stocks might go down. I'm not saying they're going to go away or tank completely, but he's going to lose money. That's for sure.
You're right.
So
yeah.
I could see both sides of that, and maybe there's a compromise that could be had that maybe reducing the subsidies over time to kind of help, or
So, not to go, interrupt you on that, but why haven't you written up your hypothesis and like submitted it just to see where you go with it?
because I write like a 3-year-old, and they would think,
Oh, well.
oh,
Type
So
it
do
up
they.
then.
So do they. They all write like that.
I mean,
be like,
the
remember Captain and Shano?
unified field theory is an open area of research, right? So nothing has come to a conclusion. So why not type it up, submit it, and see what happens? I mean, you'll never know unless you don't try.
Yeah, well, it's out there now.
I mean, it is if somebody watches this,
Yeah.
and
I'm sure a
most
lot
of
of
our
people will
viewers, I'm sure they're not scientists, but we might come across one.
I'm sure they
But-
could grasp it. I mean, I
No,
wasn't
no,
going
I'm
through
just
well.
saying
Yeah.
for the submitting it,
Yeah. There's a lot of things that I didn't really go into because it's more
Shout
on the
out to the
technical
viewers.
side.
Yeah.
Yeah.
You just got to
Thanks
make
for
a
watching too, if you did.
really cool PowerPoint is what you need.
Yeah. Well, I mean, if you can share it, if you think it's right, share it. If you think I'm stupid as hell, share it. Show
Hell
people
yeah.
how dumb I am. I don't care.
Mm.
Get it out there. At least it'll question modern day science that's stuck in the freaking mud.
The thing is, at least you tried to do it, Like, at least you wrote it. At least you, took that step to share it. So,
No,
It's
it's all
always
up
good.
here anyway. I don't usually write things down, but I kind of needed something to keep my mind. Because when I start thinking about it, I jump from here and I jump to there and I jump here, and I hope I didn't do that. But
hey, what do we call them one word? Like when this game that people play, they give you, like, you have to describe stuff, and yet you have to guess the word. Man, what is it?
Yeah,
Yeah,
like
charades.
hey,
Okay.
It's like Pictionary.
Right. Unless our video is a little behind, Ryan said Mars.
I like
So-
it. It's red.
I
I think we need to paint it with a little bit of blue to make it purple. But other than that, it's wonderful.
Was that from a previous comment about sending Elon? The moon landing was fake.
It's totally possible.
It is possible.
Yep.
I wouldn't put it past certain entities to do that. Let's say.
You know what I'm surprised we don't have is a gravity chamber. You know what I'm saying? Like, you can send this
You want a
gravity
big
chamber.
Goku?
No.
Go and sit there and
So-
train up for a while.
It's over 9,000.
The body breaks down in space. But if you had a gravity chamber on a spaceship, or the entire spaceship had artificial gravity,
Yeah.
how many years have we watched these sci-fi movies. Excuse me. These sci-fi movies, and they always had this great idea about having uh, gravity.
You know what I think our first artificial gravity is going to be? They're going to put stainless steel in each bone section. That's magnetic stainless because there is magnetic stainless. Or they're going to make make the stainless magnetic, and they're going to use a big magnetic field to pull you down. So you don't have to wear anything. You'll have plates in each major muscle group.
Sounds like it's
That's
going
gonna
to
be
be painful.
Yeah.
It will be.
That was you
but
gonna
hey,
be? You gonna be
space is worth
Wolverine? Yeah.
Yeah.
We
But
do have
that's-
like gravity chambers once again for the scuba diving world for like
Jetpacks.
if you come up too fast, you got to get thrown into the chamber and they pressurize you. I don't know if it's
you're talking about
gravity.
decompression.
Yeah, it's not really.
Yeah, that's decompression.
Reggie,
That's dangerous too.
I'm
man.
still
There's
waiting on the
hordes.
hoverboard from Back to the Future.
I'm working on that actually. If my theory is correct, I should be able to push against Earth's magnetic field using magnets. And I don't want to explain it because I don't want anybody to steal my idea, but I think I actually can do it. I just have to get a lot of metals that. I don't want to
So-
explain because then if I explain it, you'll be
Total
able to do it. And
recall.
you'll steal it.
You make a hoverboard, I'll invest.
All right.
So, Ryan said, it's 2025. We don't have cell service everywhere. What's up with that? But we can, we can communicate to the depths of space, but we can't have good cell service.
I
Well,
still
that's
don't
'cause-
even know what 5G is.
It's one more than four.
I know, but I've never like had it.
You don't
The
have
phone's
5G
the
out-
phone's capable, still no service.
You don't have 5G out there?
I'm sure we do, but it's just funny because it's like the crappiest connection you can have.
That's because space is more important than rednecks, and they know it. That's why. There
yeah,
are
I
certain
was-
places that it's hard to get into.
AI is more advanced than the cell service.
Yeah, it is.
Yeah.
But it still
Right.
lies to you. Well, just like your cell company.
I mean, you have capabilities of, like, say, Starlink, man. The best idea was taking a established cell service and giving it the capability of talking anywhere in the world by using the Starlink satellites. That
Yeah.
is a great idea. Especially say if Elon bought that cell company and then
That certain
that
one.
capability.
Wink, wink.
Oh man, hey, look, let me tell you, you would put phone services, phone companies, which I've had AT&T for a long time, but they suck. And to have something where I can go in the mountains and still have service, or be in the middle of the ocean and I still have service. That technology, where's that technology? They don't wanna give it to
infrastructure for all
us.
this.
They
Well,
don't
they-
want to
they're-
give it to us. They have it. They do.
They're too greedy. Well, that's called satellite phone.
Yeah.
They had it years ago, but they took it away from everyone.
And have you ever looked up the price? I mean, you can get a satellite phone now,
Yeah,
It's
they're
high.
wild
but it's
expensive.
crazy. Come on,
Yep.
Elon. We need good phones.
There was a rumor he was thinking about making one, but man, if he did, he would put all the others out of business because
I'm telling you.
the rest of them
that's-
suck.
Let
I
me
mean,
tell
he
you.
has enough satellites up there to do it.
Oh yeah.
I'm gonna go ahead and tell you. Look, I
Put
have
more everywhere?
Starlink. I have Starlink, and I've recently acquired the 1 gigabyte per second fiber. That Starlink service that I have is more reliable than that fiber, without a doubt. I have that system on a battery backup. We can lose power, but I can still communicate with the world. There, unless those satellites all like lose signal or something, I will be able to talk to anyone, or anybody that has the same setup.
Yeah.
He currently has 7,875 Starlink satellites up there,
Jeez.
and they're planning around 42,000.
Oh my god. How's there going to be enough space up there? The people are going to like, we need to go to Mars, and they're just going to hit a bunch of satellites on the way.
Yeah, it's going to be a problem. It's going to be a problem.
There's already a crap ton of space junk up there. I don't know how he puts it up there in the first place.
Right.
What he needs to do, instead of sending a Tesla up there, he needs to send a tractor with a front end loader, and then it can just shove all the stuff down into the atmosphere. That's the trash and the Chinese spy satellites.
Ryan says 5 gigatrons at 50. You go back in time.
Yeah, but you have to be doing 88 miles per light
Yeah.
speed.
And it's hard to come by DeLoreans these days too.
Yeah.
Oh,
I mean, you can get that part at O'Reilly's though.
the flux
Not
capacitor.
sponsored by O'Reilly's. The flux capacitor. You can look it up.
Can you? How
They
much
have,
is it?
they have the little picture.
I can make my own. I just have to bump my head on the toilet.
Dave's looking it up.
Hell yeah.
They actually show the picture.
Oh, not available for purchase.
Does it
Oh,
show
they
the picture?
discontinued, didn't it?
Yeah.
Oh man.
You can make your own with LED strings. It's probably a lot cheaper. And you can make it whatever color you want.
Nah. Flux capacitor.
Get fluxed.
Max power's 1.21 gigawatts. Hell yeah.
Well,
I forgot to mention, too, I don't think that time and space are linked the way they have them linked. Like, I don't think the faster you go, the more time slows down. I know they did that experiment that supposedly, with the clock, and I don't know if we went over that before. I remember talking about it to somebody, but I know they did an experiment where they had a clock on Earth and a clock they put in like a space shuttle doing, 10,000 plus miles per hour above the Earth's surface. And when they came back, the clocks were off. Well, yeah, I understand that, but that doesn't prove that time is linked to that. All that showed me was that you went fast near outer space or in outer space, and you exposed that clock to more of the fields and the magnetic field, whatever fields or energy it was exposed to, and you expect it to be the same clock, the same time.
now you said it was faster or slower?
It was slower, the one that was up.
I would have.
That's why
I
they-
would have. If I would have done that, I would have figured it would have been faster, no gravity, outside of
Well, no, it's still,
Earth's atmosphere.
the thing is, it's still affected by gravity. Even space shuttles are still affected by gravity. They're not outside the gravitational field. They're just going so fast that it's negating it. It's kind of like centrifugal force, right? If you spin something around fast enough, it doesn't drop to the Earth, right? That's basically why it's like that. Why they don't have a pull as such.
Right. So
They're
you seen
basically
them.
constantly in free fall.
You seen
Go
them people that came back from space look like they aged 10 years.
Oh yeah, that's because the gravity, you need it. Like,
Yeah.
You
Our
need to-
bodies
you
are
need to
meant
be
for
able to-
gravity.
yeah, you actually get taller while you're up there, and then when you come back, you
Oh, I need
shrink
to go
'cause
I need to go to space. Well,
Yeah. It's gonna go back to normal though.
I need to spend some time up there.
But you brought up an interesting point, though, because the clock itself was also experiencing that centrifugal force, that like lack of gravity feeling thing. So the clock was experiencing that too. So did that affect it? We don't know. But I don't see time. I think time is pretty much a constant. I don't think it's affected by anything. Speed,
Yeah.
no matter what we do, I don't think it's affected by any of that.
Did you see?
Well, it's
the
also
state-
like in time, we made time up.
Yeah.
Like it's our own creation.
Yeah, the
Yeah.
concept of it. Well, we know it's there because we can't like go back in it. We're subjugated to the present, right?
Hey Reggie, hey, look up that space shuttle that had the like the dead bodies, and then it had the cannabis seeds in there too for some reason.
Event Horizon?
They wanted to send the bodies to outer space, and they'd end up landing in the ocean. They had to apologize to all the families.
Jeez. It landed.
Oh,
in
I
the
think I
ocean
saw
on-
something on that. Yeah.
It landed on 420, which was ironic.
You know what? I don't know why they sent the seeds up. Maybe an experiment.
Yeah.
Yep. And it was supposed to go to space, which what gets me is why are you sending the seeds up there unless you plan on getting them back? Which they said the shuttle landed in the ocean, and they haven't been able to find it.
Well, they've been doing experiments on plants in outer space for a while now because they wanted to see what the effects of the zero gravity would
I bet
be
they
on
wanted
them.
to see the effects of DNA.
That
Yeah.
aren't accounted for. That does not mean
Oh.
they've been lost. They could be in a tree.
They're not lost. They could be in a tree.
Could be in a tree with the cat, and we just need to call the fireman.
Yeah, what the heck? That thing looks like it was ready for re-entry. I mean, if you're going to send it to space, it wouldn't look like that. I would have at least pointed it towards the moon and let it hit.
Yeah, we can hear the dinner bell.
And every time you look at the moon, your family member's there.
What, the aliens are gonna find it up there, grow the weed? Like,
Yeah.
they're gonna find a bunch of ashes and weed, and they're gonna be like, what the hell are these people
Yeah.
doing?
What do you think they thought when they found the Voyager thing and all the weird stuff they wrote on it? Like, these people are freaks.
Hmm.
You know about the plate and stuff on Voyager?
Yeah, like it was made out of gold or something.
Yeah, I think so.
Right.
They
Almost
had the
Super space weed. Ah,
I forget what all was on it.
Man.
Want to get high?
Aliens
Tally.
coming to
Space-
Earth just baked
space
out of their
high?
mind.
Yeah.
Oh man, what would you think they would do with the ashes then?
They'd smoke
Snort
the
'em.
ashes.
Yeah. Oh look, cannabis and gray powder.
They probably, if they found them, they'd probably be like, I don't like my humans well done. They
Use
don't
them as
taste
like
good
it's
well
like a
done.
seasoning,
Ah.
salt.
Ryan said that's the ship that the singers that Katy Perry flew up in.
They never got there.
Yeah. That you can't just fly up in space. You have to do training and stuff for this.
I don't know. They're probably growing stuff right now on the space station.
I think they always have like some type of plant experiment up there.
Yeah.
Yeah. They've done that for quite a while.
They say that bacteria changes on the bad side. Like say they could become more dangerous.
Yeah, it probably goes in protection mode because it's in an unknown environment. You know, but with no gravity, it's like, what the hell's going on? I imagine, normally bacteria is like oblong, but under zero gravity, it probably like squishes in, changes its shell somewhat.
Hmm.
So,
Yeah.
and just little changes in the shell. But the shell of bacteria is like the shell of your cells. It's got receptors for proteins, right?
Right.
So it could, who knows what zero gravity would do to that? And if it develops a protein receptor that your body doesn't have, oh yeah, it could be some bad stuff. Because your body has in your plasma is a whole bunch of different proteins just floating in there, right? And if a bacteria gets in and your immune system doesn't have that protein to be able to defend against it, that's when you have like these super, like bacteria that just eat your flesh.
Yeah, it just has
Because-
free range of your body.
Yeah, because you have no immunity to it whatsoever. It's scary shiz, man.
All that flesh-eating bacteria.
We have that down here. It's ridiculous. I'm like, where did it come from?
Yeah. Years ago, we never had that problem. Now, all of a sudden, it's everywhere in a warm body of water.
All right. Oh, you went tubing. Now you don't have legs.
Thanks, Obama.
Probably, you know.
I got Reggie with that one.
Yeah, we have it here on our little tubing river too. Everyone's like, "I'm never going tubing again." I'm like, I didn't want to in the first place. That river's dirty.
You got MRSA too. That's going everywhere. I said this a long time ago. When you clean a slate, when you wipe out every bacteria off of something, you wipe out the good and the bad, and usually the bad will survive.
Mm-hmm.
So you're
Kinda
making a
like
clean slate for
cockroaches.
bad bacteria. Yeah. Bad bacteria is far tougher and stronger than good bacteria usually. So when you Lysol stuff and it kills 99.9% of germs. Well, that 0.1% that's left over is going to screw you over, dude. It's going to eat your fingers off.
I got one cutting board and I don't wash it.
Just use regular soap. Don't use that
I rinse
antibacterials.
it off. But
Well, when the the virus was going around, I'll say that Russia did experiments on it with like soap and different things, right, to see what killed it. And they said that just water
You want to
itself.
talk more about space?
If you want. What do
Okay.
you want to talk
No, no. He,
Do we think there's undiscovered killer germs in outer space?
we probably created it.
Well, they say that we found bacteria on Mars and stuff. Now, is it killer? Probably not. I think a lot of stuff gets mutated here by our proximity to the sun and the radioactive elements that are here and all that, and plus humans themselves. You need life, like more complex life, to mutate stuff like that usually because it has to survive amongst all the other things. So if you find one or two bacteria in outer space, I wouldn't think they would be too bad, like too deadly or anything. They would probably be pretty benign because there's no competition, right?
what about fungus? That's what I'd be worried about. Space fungus.
Space fungus? Oh yeah, that's some bad stuff. Get it on your toe and it's just like growing a forest down there.
So Barker said, if radiation is stronger in space, what kind of effect does that have on the cells and bacteria?
Exactly. It'll either do one or two things. The life will either find a way, or it'll be too much radiation and it'll just kill it.
The record was skipping.
Yeah.
Now, I did read an article about if a person was ejected into space, he would like suffer severe sunburn in a matter of seconds. So they said they did have a monkey survive. The monkey was in space for 3 minutes. They got the monkey back and was able to resuscitate, and but it had severe burns.
And it went on to give a good TED talk too. Yeah, the radiation up there is very severe, but they say that like the Earth has gone through different phases, and so our complexity of life we have here was due to the radiation. That's what they say. The radiation caused mutations to occur and caused life to flourish because they still can't explain the KT explosion, the Cambrian explosion. They have no idea why there were so many different varieties of life during that time. But it could be just because the fossil record is so, it's missing so many things,
Right.
There's a lot of people who, oh, go ahead. What, you got a comment?
Oh yeah, a couple. Okay. So the one, okay. He said, "Poor monkey." I imagine PETA is going to be all over that. No, that
They
probably
didn't care
happened.
about the beagles.
See, that probably happened years ago. So now no one's held reliable reliable. How they found that when we'd never been to the moon. Uh,
I'm looking at that Cambrian explosion.
Well, I was
That's
gonna
when
say
everything
too-
was cool looking.
Yeah, it's weird looking creature. Uh, I was gonna say too. There's scientists often say that they 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 discredit the Bible because they say that God, in the Bible, he said He created the birds first, kind of thing, right? And the scientists are like, well, we don't find their fossils. You know, we find these other fossils. We don't find any birds fossils until this point in time. And I'm like, well, yeah, but birds' bones are hollow. They're not going to survive most of the time. They're fragile. So you might not find them in the fossil record, right? Or if you do, it'd be very rare.
Right. Aren't like a lot of the bird's bones, like they're not hollow, but they kind of are, just for
Well,
like being lightweight.
Yeah, if they're a bird with flight, they're very light and they're hollow, like very brittle. Well, not brittle, but not as dense as like ours and land-based creatures. So that to me would explain why you wouldn't find them, because they degrade faster. Be harder for them to survive. Not saying that's true. I'm just
plus,
making a case for it.
perfect example is chickens, right? So you have 10 eggs. Majority of the time, you're never going to get the 10 to hatch. You will probably get, say, a good possibilities 40-50% you're going to hatch, right? I wouldn't say they're fragile, right? So you're going to lose probably 50% of what you just hatched. And it's just a
Yeah.
given. You know what I'm saying?
And that's on a good day.
Yeah, you can do everything right. You can have the humidity if you're incubating. You can have the hen laying. And there's going to be some that don't make it. That's how fragile a bird is.
Yeah.
Temperature can play a role. Bacteria can play a role. I mean, you can do everything perfect. And we're still going to have some. Dang, there you go.
That's that Japanese one. They like that bird.
Bill or something, hornbill.
I think so. Forgot the name of that. Is that one?
Ha.
That's the one they did in Skyward Sword. They put, remember? Link was
Barker
flying
said
out.
the next study will be sex and birth in space. How that will affect the
I'll
human
do
body.
that. I'll do that.
They probably already did that. The first
Yeah, they
alien
are up
was,
I thought they asked the astronauts they just brought down about that, and they said it's almost impossible to have sex in space.
Okay, I need to go up there and disprove that.
I wouldn't want to be the one to clean it up, that's for sure.
Oh, it'd be floating around and hit you in the
Exactly.
forehead.
Just
Whatever you
walk
don't
in.
go in that chamber. Don't go in that chamber.
Oh,
over
heck.
there.
Oh, you had your mouth open. What?
That chamber needs to be cleaned. Don't go in there.
Yeah, we have to get a spaceship and try it. Yeah.
Yeah, I'll start building it.
Oh, man.
I got enough spare parts laying around.
Oh, yeah.
I wonder why they would say it's almost impossible. I mean, there's cameras everywhere. Is
I
that
think
why
that-
it would be impossible?
You could probably search it.
Probably.
I'm sure there's something on it. I could have swore they were talking about that. Somebody questioned it already.
They don't want to fog up the equipment in there, probably. It's very sensitive stuff.
Wonder if it'd be an alien baby.
It would.
Didn't- because it wasn't conceived on Earth.
Yeah. It would have no country.
It'd get deported.
To space. Out of an airlock.
I mean, yeah, since they can.
Yeah.
There's no
Their
rule
movements would
against
counter
it.
each other.
Hey, put that on 20 seconds, Reggie, and let's see that again.
It said their motions would cancel each other out because equal and opposite reaction, and there's no weight.
Yeah.
So you can thrust all you want, you're not going nowhere.
Yeah.
You know what I'm saying?
Oh, yeah. Ah,
Yeah.
Barker said super sperm from space. Make the next Superman. Better get that green card.
I just think that we need to do some further research.
You
I think it'll-
volunteer?
Yeah,
If we
I'll
go to
I'll
if we
up.
go to Mars, I'm sure somebody's gonna do the nasty in that shuttle. It's like what, a 3-month tour.
Oh yeah.
Somebody's gonna be a Martian.
Well, heck, that's like them 2 astronauts got stuck up there for what, 8 months?
You got something crazy?
Yeah.
You're telling me that the dudes weren't jerking it? Come on.
Reggie and Katy Perry on the next shuttle.
We're actually gonna go do experiments, Katie. Come with me.
You should see the view from over here. In this portion of the shuttle with no equipment and cameras.
Further research recommended, Barker said.
Research inconclusive.
Yeah, you're gonna have to have multiple attempts to like weed out any variables.
And different
Yeah.
ones with different
Yeah,
body builds.
You have to develop a special suit just so you can do it in space, you know? Like, it's got magnets that
Or a
suck you to
special
each other.
room.
Yeah, just have like a robot
Yeah,
chair that
special.
just shoves you into them
Yeah.
and just pulls you back and forth.
You're
Yeah.
like on rubber bands on each side of the room, right? And so you smash together and then you...
Yeah.
It's like a swing. It's already designed, man. Just use the swing.
What they need to do is just they need to make a spinning space station where it makes
For,
gravity.
Like gravity.
Yeah.
Yeah. That would be hard to do, huh?
It'd be like the Gravitron at a fair.
They're still around? They banned those yet? Because those things are
They're
dangerous.
fun.
Are they?
I like them.
Go upside down, get yelled at.
I always wanted
Standing
one.
straight out.
I wanted to be a billionaire and have one myself and work out in it.
Yeah, there you go, dude.
Do handstand push-ups in it. Crank it up. Go faster.
Dude sitting in the middle just jamming.
Yeah.
Throwing stuff at you. Catch
Yeah,
this
you have
knife.
to dodge it. I'm gonna do a somersault. Oh, broke his neck.
Like dodgeball. The wrenches.
Yeah.
If you can catch a wrench, or if you can dodge a wrench, you can dodge a ball. Oh my! Barker
I've
said,
I've
just a
been
little
on
bump and
Gravitron
grind.
Years. I don't even think I've seen like a little city fair around here in years.
I don't know, man. I don't think I could ride any of them rides anymore.
Why is that?
No, not just on top of my weight, but I would say,
My hand?
Your judgment on their
Back,
bolt
probably.
tightening abilities.
yeah, I've seen too many things fly across, fly off, and even at the world-known locations, like you ain't getting me on a roller coaster anymore, buddy.
They are a little sketchy when you start really like thinking about like when's the last time these all got tightened?
Yeah, serviced.
What's the
Tight
inspection
cut.
date?
Yeah, pencil whip. That's a thing now.
Oh yeah.
Yeah, and
Been
they're probably running on hardly any staff too.
Mm-hmm. That
Especially
cocaine
Disney.
and energy drinks.
Bleeding money at Disney.
You know that what comes to mind when you say that is Joe Dirt
Oh.
when he's working at the fair. Yeah, that's the type of guy inspecting your ride.
He's the one working the Gravitron.
Hmm.
Wasn't he working the Gravitron in that show?
I don't know what it
I
was.
thought it was one of them.
Don't forget to put Pam on your little coin toss.
Found that special media, yeah.
Oh yeah, yeah. That's no space meteor.
That's a peanut. That's a space peanut.
Or how about when he's trying to rob the bank? Or no, he's trying to get information
Yeah,
from the bus
he
stop.
hits the thing and it.
Yeah.
poop That's an old septic tank. See? always wanted to go into like I wanted to be a physicist. I really did. But
You still got time? Just get back to school.
Yeah.
I don't have
Dude,
the
there's
brain
like
for it
there's
no more.
80-year-old women graduate college.
I'm surprised I could explain what I explained because of the damn COVID brain I've got. I'm not kidding. I was trying to think of stuff half that time, and I'm like, what the hell am I trying to think
Ryan
of?
said, "Yeah,
I can't
put
do it
some
no.
lotion on that skin."
I was thinking that earlier when you said
Joe
having
Dirt.
sex in space. I was like, what if there's a room with a hole and you like,
Oh my! Barker said, "Drop some acid and get on the Gravitron."
Mm. You're just gonna fucking vomit all over yourself.
Yeah.
No, I tried to go back to school, and I had no interest in it. I did like 3 classes online. I'm like, I'm good.
yeah, I would love to really, but I can't. My brain don't work no more. It's not like it used to be. Like I said, I came up with this theory like 20 plus years ago. I was like 20 years old or so when I first started the initial, the infancy phase of it. And I've refined it over the years, but
Right.
it's
Yeah,
been
Like I said, make a PowerPoint, type it out, put it on the website, call it a day.
yeah, I'll try. If I get time, I got so much to do. It's unreal. I got to build that generator still, and now I got to work on the hoverboard and the flux capacitor. Yeah.
You did get a generator. I heard that was a problem.
No, I want to build one.
Hmm.
I want to build my own with my idea of one.
That's why we're having this the show on today.
Oh, you talking about the power outage? Yeah.
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 I can't afford a generator. I just need a treadmill. I just got a
Get
treadmill
somebody
all the
run
time.
on it.
Yeah.
Get a big old fan. Get a wind generator.
Ryan said I could have been a doctor, but I dropped out. Yeah.
What, you dropped out of your mom? Ever since that doctor slapped me, I hate doctors. I wanted to be one, but he slapped me.
I think I was gonna, after the army, I was gonna go be a nurse, and I was just like, no.
Reggie,
Hell no,
how's
I'm-
Disease's volume on his mic? Like progressively getting louder.
Oh, it's louder?
Like
Usually
all
gets
of a
lower.
sudden went loud.
Yeah, I think it's that Riverside. Riverside's the audio's weird on it. Like sometimes you'll play stuff and someone will talk and it'll like do the echo or the like compression goes weird. I don't know, I've noticed that. They need to fix that. Yeah.
Yeah, now it's fine.
Quiet. Put the lotion on his skin.
Oh, he's got one of those holes in his room.
Barker said, who the hell can afford education?
Yeah. And then you don't learn anything at the
Yeah.
things nowadays. You learn how to
You watch YouTube videos
Dumb.
and then write about the video.
Yeah.
That was my entire last class, was watching business TED Talks, and then they wanted us to type out 3 pages on the video, and you're like, what the fuck?
And now it's worse because they want you to watch a video and then you have to use AI to type up your stuff for you. It's so horrible.
Right. I
This
love
isn't
that.
AI.
You can't use AI, but you're going to use it. I guarantee it.
Mm-hmm.
You're going to write all your questions in AI. I know it. I would.
I like my questions to be free range. Like I like my chickens.
Yeah.
Yeah, college ain't what it used to be.
Got a little gnat in here somehow.
They're driving me
contagious.
nuts.
Keeps flying like dive bomb in my face. I had to catch him. But yeah, man, education's out of insane. I think it's more. I think the colleges now are used more to I guess, what do you call that? Indoctrination.
Mm.
So they can, if they need a certain kind of party, what do you call? Say if they need a certain kind of party for voting, then they can literally brainwash them in the colleges.
Yeah.
Yep, that's part of the problem I was talking about earlier. That's not focused on actually educating people and getting us to the next level in our, you know, uh, technological evolution. It's all, oh, what can we use these people for, right? They don't care to actually advance society as a whole. They only care to advance their own interests. And college follows suit with that.
Barker said, "What about the guys that use AI to pass medical school and then become doctors? I
Oh,
want
that's
to be
scary.
the I want to be the first in line for the guy to be my doctor."
Yeah.
You know, I'll let him take a swing.
Why did my proctologist tell me to open my mouth and say ah?
Mm-mm-mm.
I'll let him try once. You know, but if he fucks up the first time,
I didn't. So he wasn't supposed to have two hands on your shoulders.
Yeah, the U.S. is in deep doo doo right now between all that because we have a workforce that does not know what they're doing, and that goes from the top down. You know, doctors and stuff. Not saying all of them, but you know, if you're passing all your tests using AI, I want to know so I don't go to you. You know, the doctors are probably about to be replaced by AI anyway, so it's like, well, what's
oh yeah.
the difference?
Once the AI starts doing the surgeries by themselves without doctors being there, it's over for them.
Barker
Yeah.
said it can't be any worse than the VA healthcare.
They do me pretty right. I mean, they, you know, everything seems a little old.
I don't know, man. I think we go through more doctors. You never keep that same one.
No,
Then you have to
I don't even know
explain
who
everything over again, even though
I
they
don't
got
even
the
know who
files.
my primary care provider is right now. No idea. And they're not gonna. If they leave, they're not gonna call me. It's gonna be me making an appointment and them going, "Oh, you don't have one." Okay,
No.
well, let me get one. They go, "Well, it's gonna be about 3 months before your appointment." Like, okay,
That sounds like the DMV.
I kind of wish
it's very similar.
Kind of wish I got a new doctor, man. The one I got now is a straight up asshole.
I think I've seen mine once in the last year and a half.
Hey. Well, I have to see mine. I've been, I have to go to, been going to a specialist about my back. And that's one thing I need to research a little more is that they want to laser the nerve in my, like, lower back. Because, well, the doctor that I have now, which is not affiliated with VA, he's a neurosurgeon, and said that it looks like I had an impact and it pushed the, I don't know, I don't want to call it cartilage, but in between the spine, the bone.
Your discs.
Yeah, pushed it into the bone. So when I don't know why they didn't catch it at the VA. You know how many MRIs, CT,
Yeah.
or whatever, X-ray, whatever they do. They do so many, and then this guy takes one and it's like a 3D. So he rolls it and you can see where it pushed in. And he said, "Oh, this is an impact injury." I was like, "Yeah, I was in the military." He's like, "Yeah." He's like, "That I would say that has to do with, you know, your military career or your life." And I said, "So the VA's trying to tell me that it's from childhood." I said, "I haven't had that kind of impact or, you know, any kind of injury like that."
It's crazy that they would let you join with that.
Well, that's crazy that I didn't hurt back then either.
Right.
And then afterwards, I'm like, but
Yeah,
yeah.
they're just like every other insurance style. just
Yeah,
deny
yeah. Yep.
as much as they can, get in
God,
your
I just thought
way.
of something.
Oh yeah. Barker said they will just have AI do the surgery, so you can be the first VA test subject with AI surgery.
It's gonna be VAI.
Yeah. Nah, but yeah, man, I don't know. I don't know about that lasering because would seems like you'd lose filling, and then you could further damage, and then I could be crippled.
Yeah.
Yeah, that's
Let's
a
get
little
it pumped
scary
up
when it
with
has to do with the back.
shoot it up with steroid and stem cells and shit.
They've been in doing the injections, and I find it feels better, but it just goes back to
Yeah.
hurting. So, and that's when he said, I don't think we can keep doing this.
Yep. I would go down to Bogota, give me some fucking stem cells, get on some
I go to-
HGH.
Go to Wolverine's doctor, get a whole new metal back and stuff.
Yeah.
Adamantium. Adamantium.
It'd be just your back adamantium though. Everything else is still bone.
No, if they go on that far, do it all. Except for my package. Gotta still have filling.
Nah, make that metal.
Yeah.
Yeah.
Shoot lasers too.
Reggie's smiling. He got something up his sleeve.
He's cooking up or something.
Yeah.
I just thought of something I was gonna. Never mind, it's too late now.
About.
Oh, it has to do with the theory thing. It was something to do with the theory. I just wanted to make a correlation. I forgot about it. I can do it real quick if you want, but it's. Remember when I was talking about when the star explodes, right? And the pieces that get recaptured and they become the planets. I was going to make a correlation with a magnet, right? If you have a magnet and you break a little piece off of the magnet, you have two magnets. You just have a larger one and a smaller one, right? So that's the correlation I was going to make because it's basically the same material or similar material. So once it separates, you have two of those now, and they'll push against each other, and that's why the planetoid one won't be absorbed back in if it's sufficiently large enough. But it's too late to make that now. I waited
Well.
too long. People didn't stay long enough to reach the end, didn't get it.
Well. Yeah, man. So, other than the theory, how's everything else been going with you two? It's been a little while since I've had you on here.
Going good. Like I said, it's hot here now. It kind of sucks.
Yeah, is that dry heat or humid?
Oh, it's dry.
Right.
So nose burn dry, like San Antonio.
We've had rain for maybe 2 days in the last week, and it was like 10%. Like it was barely any. And that burns off pretty quick, and then it just gets so humid that you can't even go outside. You just start sweating. But it's like everything's dead. All the anything that was alive that was a plant is just dead. I got to take my dogs out at night now because they can't walk on the sidewalk.
I imagine it's hot.
Yep.
What are you in Death Valley?
Get them some boots, man.
Fucking basically.
Yeah, we got that stupid humid heat here. It's not as hot, like temperature-wise, but it drains everything out of you. I remember being a kid, though, in the middle of summer, playing basketball for 5 to 8 hours and not drinking a drop of water. And I had a headache afterward, but I was okay. I
Right.
couldn't do that now for nothing.
So, Barker, got a question for everybody. You had a chance to dig into the big, beautiful bill?
I've seen bits and pieces of it.
Yeah, I'm not a fan of it. I don't like the idea of packing a lot of stuff into one bill that have nothing to do
Yeah.
with one another.
She had
I've
started
never
off
been
at
a
like
fan of
100
that.
pages and ended up 900.
Yeah.
They
I'm
always
sure
do, though.
it's got some good stuff, I'm sure. It's got some bad stuff, I'm sure.
All those other pages are concessions. You know,
Yeah.
they do what they want. They say the initial thing, and then they get in there and they're like, oh well, if you want this, we need this, and if you want this, we need that, and then it makes it 7,000 pages, just like Obamacare.
Right.
Yeah.
Obamacare was like I think 900 pages, and then it ballooned over 10 years to like 10,000 or something. I don't know. Don't quote me on the numbers, but it was a lot. Like, what are you filling that with?
Yeah, rich
right.
people, rich people win in the end.
Yep, it always happens. I fought
mean-
with AI over that. I talk to AI every now and then about stuff like that just to see how. Yeah, I just want to see
Oh.
if the AI is going to tell me the truth or not, you know. And I fought with AI over it and being like
I-
about the corruption, and I eventually had it where I was like, okay, well, I believe you're 95% correct about the corruption. And I'm like, why not 100? He's like, well, I don't have facts, but by the correlation you've made, it's like, okay.
I talk to AI when I'm lonely too. No, I'm
Oh,
just kidding.
you got any girlfriends?
No.
I've talked to the AI about my theory a few times, and surprisingly, brave AI makes some of the leaps in logic that I'm like, it got it, it understands it. Whereas,
Yep, somebody else got it and understands it too now.
Great, you
Did
created
public-
a super AI.
Didn't publish that paper in time.
yeah, it's all right. I was 20 years ahead of anybody else, and that's all that matters to me. Um, yeah, what's funny is I posted part of it on my MySpace page a long time ago.
MySpace.
My-
Telling
that's
ages
all-
I don't
now.
even remember the last time I was on that.
Telling ages.
If somebody could pull that up, but I think they wiped MySpace back in like 2014, so most
I
of the
thought
old
they
pages
still
are
had it.
gone. It's still there, but most of the old pages are gone. Like you had a page prior to that time, it got wiped. So I tried to log into it just to see, and I couldn't. I couldn't find it.
MySpace.
All
Back in the day.
the old friends list. You can move them around and piss everyone off.
Yeah.
Dude, I'm not in your top 8, dude. You're like, oh,
Yeah.
no.
Yeah.
Remember I invited you out and you said no. Now you're number 9.
Oh man. It throw a wrench in Facebook doing that.
I mean, fuck, I forgot when I got rid of my Facebook. It was probably 7 years ago. Something
Yeah.
like that.
I haven't been on it in a long time.
Tell you what, man. Like I told you before, it was hard tracking you down, but I did it.
Yep.
Couldn't find this dude on nothing. And when he has a couple social medias, or at least one, which his name is not even on there.
Mine ain't either.
Yeah.
Yeah,
Yep.
that's the best way to be. I'm not linking my stuff because that's how they track you.
Dude,
Damn government.
I went through all kinds of things like DOD. I'm trying to make sure you're still okay.
I'm alive. Still paying bills.
Still paying bills. Yeah, I
In
feel you
this
on that.
sad reality that we live.
That's all I have anymore is bills.
Yep. That's what I look forward to every time I get paid. I'm like, man, I can't wait to give this all away.
Yeah,
They
just
keep me
got it
warm
now. It's like one big circle, man. Going back to the same people, if you think about it.
Yep.
Well, at least you got paid that penny. I haven't
Yeah.
seen anything yet.
Yeah, they're a rich man.
That penny. Yeah.
They don't make those quarter pence pieces, in the U.S. anymore. Otherwise,
Where
can
you
pay
break
us.
them all down, yeah.
Like the half penny.
Well,
You pay us in pesos. They're like 3,000 to 1 penny or something.
well, I mean, save up a couple checks and then go to Mexico and live.
Yeah,
Or
the cartels.
or don't do that, and you can go to Thailand.
I'd go Philippines, Thailand. I'd probably go Philippines.
Yeah.
Vietnam.
So I priced a ticket just to see if I left here and went to Thailand, it would cost me $600 to fly there, and then when I get there, I can rent an apartment for $75 a month, and then get internet for like I think it was like $8 a month, something like that.
Dang. With my disability rating, I could just go live there.
That's what I was saying.
A lot of people do.
My disability rating, I could just go there, and then like say if I needed a little extra to travel or something, you can volunteer. You just have to get you a visa, you know. But
I wouldn't go to the Philippines though. They got gigantic saltwater crocs there, and I don't want to go anywhere they got them.
Hell yeah.
well, I'm not going swimming. Everything there probably kill you. Kind of like Australia.
I might do the Vietnam. Vietnam would be a fun one.
Yeah.
Yeah.
Hey guys, sorry about that. Sorry about the '60s, huh? No
Yeah.
hard feelings.
Oh man. You'll just go missing.
Right.
No. Hey, Europe was nice, man. But it's probably taking the same toll as we are here.
Oh yeah.
So,
They're far more progressive there.
well, guys, if y'all don't have any more on the theory or any more to add, we can go ahead and go close it.
Yeah. I gotta get my dogs outside to go poop at some point.
So,
And I
in the
gotta go eat.
future, though, so there's some people that's been watching the show. Want to thank y'all for tuning in, but I also want to let y'all know. Not only do I have music artists on the show, it's called BSing with Y Eagle Y for a reason. Like we BS with anyone. Man, you have something you want to talk about? Y'all hit me up in the comments. You know, it's not just set at one genre or one topic. So, want to thank everybody for coming out tonight, and look forward to seeing y'all the next show. And don't forget, you can look in the description, get 10% off code with W. You can get your hydration drink right there, man. Hydration. It's a powder, or you can get the energy one. It's all clean energy, clean hydration, no sugar. So check it out, and I look forward to seeing y'all next time.
See y'all later. Ball.